Great. All right, well, I don't have hand-drawn slides, and I don't have anything about the Bauhaus movement. I do have some scribbles, so that'll have to do. There's a hand-drawn slide. I also, similar to them, I come out of a art background, trained in theater, but no school background, no library background, so I cross those off. I'm going to talk about style guides, kind of. Everybody loves style guides. They're the hip new thing. You've got the Lightning Design System from Salesforce. That's very popular. It's a well-done system. Here's a grid system from the MailChimp style guide. There's color guides. There's this letter M, which comes from the New York City Transit Authority Graphic Standards Manual, which was released in 1970. It also has the letter N, the numbers 5 through 8, and this page, which is what I want to talk about. This page is the sign design for where those letters and numbers are going to show up. This is actually how you build the sign that is going to display your design. So I see how you designed it, but I want to know how you build it. And that's what I want to talk about. Because patterns, consistent design patterns require consistent code patterns. Consistent implementation is how you get consistent output. Now, context matters when we're talking about building patterns on the web. I'm going to build different patterns than Salesforce because I'm in a different context. Your team size and your structure of your team are going to affect how you do patterns. Are you internal or are you consulting? Is it 1970? That's going to change what you do. You're probably not going to be doing web patterns if it's 1970. We all have similar problems. We're solving similar problems. We're dealing with grids. We're dealing with typography. But we have different constraints. And those should be allowed to affect what we do, which is why Bootstrap isn't the right solution for everybody. So this is my team, or this is where we started. That's me and my brothers doing a card sort, I guess. I think that was Magic the Gathering. Our team is now 7 people, so it's still a very small team, and we're doing outside consulting. So that changes how we work. We're not building Bootstrap because we're not Twitter. We're not building the Lightning Design System because we're not Salesforce. We're building systems for system building. We're going to hand off a system to a company, and they're going to take it from there. So I first learned about this technique from Natalie Down, a talk she gave in 2008. So this isn't really a new idea. But her basic idea, she was responding to some of the early CSS systems that were released, Bootstrap, not Bootstrap, Blueprint, and some of the others. And she was saying instead of having these consistent tools that build the same thing for everybody, what we need is consistent languages within our team to develop a new system for every project. She was in a similar situation to us. She was doing client work, so she was handing off a system to internal teams. So that's where Suzy came out of. Suzy is a tool that I developed, a grid system, and that came out of our need to have different grids for every site and lots of flexibility around them, but a consistent language for doing that. I don't use grids anymore. You probably don't need grids. But anyway, we're building consistent systems, but they can generate custom patterns. So something about the way that we work is consistent from project to project. We know the language. We know how we're going to do things, but we're able to build custom tiny bootstraps for every client, as Dave Rupert said. So for us, the product is the architecture. We're building a solid foundation to hand off to somebody else. A pattern API, pattern in code that we can hand off. So not just the style guide, but the way of using the style guide, the actual code to make it happen. So a code pattern combines languages. It's going to involve design. It's going to involve HTML and CSS. It's going to involve JavaScript. It may even involve the back end. A code pattern is an integration of everything that goes into the style guide. The style guide is not just for designers. The style guide is not just for implementation. The style guide is an integration of all of those things, and it combines all of the languages. And so you have to have maintenance of the style guide integrated across the whole team, and maintenance of the patterns integrated across the whole team. So everybody understands what patterns they're working with and what they're going to do. There's a common rule for building patterns in code, which is not to repeat yourself. Don't repeat yourself or dry. There's another less known rule, which is don't stretch for patterns. So make sure to remember that. It's important to remember that you can build one-offs. Often home pages are a one-off or involve lots of one-offs. That's okay. The idea of pattern-driven design is not that everything fits into a pattern, but that you understand when patterns are happening and how to use them. So it's okay to build one-offs. This is not a pattern. Two elements that share a border style is not a pattern. That's not enough. If we start building patterns around something this flimsy, it's all going to fall apart as soon as we change one thing. It's important that patterns add meaning to your code. So it has to be two elements sharing a purpose that drives a pattern. So if both of these elements have the same border style because they mean the same thing, that's a pattern. So that could be, these both have a red border because these are both alerts. So that's enough meaning for a pattern. And a pattern, our rule is 2 is maybe a pattern. A one-off is fine. Once you have 2, maybe, but maybe not. Maybe you're okay still copying and pasting. Once you get to 3, you're looking at a pattern. So Sass should also add meaning, and that's one of the reasons I love Sass and use Sass. Yeah, you could use another preprocessor for the same thing. But you can see here, taking a bunch of grid math and turning it into something meaningful with functions. So you can look at that bottom part and say, okay, I understand span 3 columns. That means something. That means something more than the math there. In case you forgot, CSS was actually designed for patterns. CSS came out because we had inline styles, and there was no way to have a pattern. So a class is a pattern. That's what classes are for. So we already have this built into the language. You don't need Sass or something else to get started with patterns. Patterns are built into CSS. It's the reason CSS exists. And working with CSS, this is just a quick specificity is your guide when you're working with patterns in CSS. This is the inverted triangle by Harry Roberts, which talks about reach, specificity, and explicitness. The broader your reach, the less specific and the less explicit we want to be. So something like an A tag, if you're targeting an A tag, that's going to have a broad reach. So we want to keep the specificity low and the explicitness low. And they are in that case. If you're just targeting an A tag that has a low numeric specificity and it's not very explicit to what it's targeting and it has a broad reach. And then you want to work your way down through that funnel, through that triangle, but staying in the shallow end as much as possible. That's going to require naming conventions and keeping those conventions consistent across the entire team. We often, at the beginning of a project, will start by just naming everything in the project. We'll say, okay, this is all the data we have. Let's get consistent names across the whole team for this data. And then that extends out into patterns. We're able to make sure that we know we're all talking about the same things. So this is similar to the triangle. Patterns are going to happen in layers. There's going to be different layers of patterns. Some are more abstract. Some are more concrete. Some get very specific. So, a pattern might be your colors. and that's pretty abstract. Or a pattern might be a notification fly-in, and that gets very specific. So you've got different layers of patterns, and making sure that you understand where you are in the triangle, in the layers, is helpful. And Sass partials or something similar can help you get organized, breaking things out and organizing them and labeling where your patterns are and what layers they're at. There's lots of systems out there. I call these the brand name systems. You know the brand. There's Atomic. Inverted Triangle is fairly new. SMAX, OOCSS, BEM. They're all great. The people that designed these are brilliant. And they're not good for you. You can use them, you can use parts of them if they fit, but there is none of these were designed for your project. And they are all useful to learn from. So I highly recommend reading through all of these and then ignoring anything that doesn't work for you. You need your own system, you need something that works for your team. There's not any right answer to this, but there are plenty of wrong answers. Which not having an answer is the main wrong one. You're going to need to worry about separation of concerns. This is also important and blurry. It's not always clear what is presentation, what is interaction, what is structure. That's not always clear, but it's important that you are making those decisions and you're making them consistently across the project and explicitly with the whole team. So separations of concerns, that's important even if it's blurry. So I'm going to look first at some abstract patterns in code. How do we represent a style guide or a color palette in code? Here's the old way, color variables. I mean, this is not the oldest way. But this is one common way to do it in Sass. So we've got color brand orange, color brand blue, and various variables. And it's fairly easy to use. You can access the colors directly by their variable name. But it has some problems. Those colors aren't grouped in any way. You can add a color anywhere. There's no final list of the colors. The computer doesn't understand the grouping. So we can see that these are all colors because they all have color in the name, but that's not a system that is structured. So I moved to using color maps. These are Sass maps. You get a key and a value. You probably recognize maps from other languages, including, say, CSS. So we've got one color variable and all of our colors grouped within that. It's a little bit more complex to access. Just using the basic Sass, you'd have to use map get colors and then the color name. So it's a little clunkier there when you're accessing it, but it has logical grouping. Maps provide a meaningful structure for colors for that abstract pattern. So quick, what's the relationship between these two colors? We want to show that as well. But there's a problem with maps, which is if I'm trying to desaturate this color 80%, I can't do that. Because at the point where I'm trying to manipulate the color doesn't exist yet. That variable hasn't been fully defined. So that's a problem. How am I going to show the relationship between these two colors? So I've found a workaround, and this is how we do it. This is define now, calculate later. So I will define in the map what I want to happen. I want to take the brand blue and desaturate it 80%. And I'm not writing out a function there. I'm just writing out the name of a function and the arguments to pass to it. And then later, I will use a color function to calculate that, figure out what the output should be, and give it to me. So that's my solution. And I'm very happy with it. It keeps all our colors grouped, and I actually group colors at layers because to me, even within this abstract pattern, there are layers. So I start by defining them with color names, and then I start giving those color names turning those color names into other colors in my palette. I have my base colors, and then I sort of create a palette from that. And then I have how am I going to use them? So what is a border color? That's going to use the brand blue, desaturated 80%, whatever. So I can have these different layers of the color system and access them at whatever layer I need to at a given time. So is that over-engineered? I hear that a lot when I'm showing the crazy things I do with maps. Sure, maybe that's over-engineered. But it's readable by humans and machines. You can look at that and see how the colors are related, how they're grouped, and the machine can also know that these are grouped and they're part of the same system, and I can cycle through them to access all my colors directly. I don't need to list every single variable that involves a color there. So those are all grouped in one place. And I can access them dynamically. This is the whole reason Sass maps exist. People ask for dynamic variable names. And Chris and Natalie said no, but here's maps. So maps have dynamic naming and dynamic access in a way that variables don't. So the other thing we want to do is make patterns the lazy option. And this actually, using maps helped with that. At this point, now when anybody is in one of our projects and they want to add a color to the project, they have to go back to the config file where we have the color map, and they have to add it in place. And that means those colors are all documented in one place. They're all in the same file. They're all grouped together within a single variable. And I can access them using another piece of software. So we're working on Herman. It's built on SassDoc. SassDoc is a great tool if you need to document Sass. It uses inline comments to write your documentation, and then it generates something. So we're using SassDoc comments, and then we've added a few of our own little tricks to it, like preview color palette, and it understands the way we do colors, and it automatically outputs the palette. Because, again, the computer understands the system, and that helps us automatically generate something based on colors. Anytime we add a color to the map, that color is immediately in the style guide because the computer understands it. So we do the same thing with sizes. If you're doing a typographic scale, you can start simple or start to add in, again, this is using my define now, calculate later technique, where we say, okay, I'm going to want to take this up a fifth, or I'm going to want to multiply it by 3/4. So I can create a scale that way. I can also keep my fonts in a map, and then the system knows what all my fonts are. And again, exporting through, this is how we get the data into Herman. We do a JSON export, and suddenly we have typography in our style guide, combining all of our sizes with all of our fonts and generating right away a font specimen. So again, is that over-engineered? For some people, probably. There are projects where you don't need that. There are projects where that's not going to be useful. For us, we're moving from one project to another quickly, and we have a small team. We don't have time to dedicate an entire team to building style guides over the course of 3 years, like Salesforce. I don't know if that's how long I took them. We don't have the time for that. We need our style guides generated very quickly based on code patterns, and so that's what we do. Also, I think over-engineering is part of the process. That's how you build a good tool. You start by building too much. This was a CSS-only tabs thing I was playing with. And this was the initial code for it. I made a little plugin that would do CSS-only tabs. And then I tried to use it at various places, and it was too opinionated. It did too many things. And what I ended up with was much simpler. This just takes an input and toggles something based on the state of the input. And that's all that I needed for the tabs. And that let me do tabs or accordion or anything else. Because it wasn't opinionated about the output. It only cares about the very specific abstract task that it's taking care of. Yeah. So to get there, over-engineering was where I started. I first built something very specific to one need, and then when I tried to reuse it, I found what is essential. Toolkits are a byproduct. All of these toolkits come out of our work and what we need to do, and we build something and then we adjust it, and we make trade-offs. So using maps for colors and fonts and sizes comes with trade-offs. There are reasons you might want to use variables. There's many different ways you could do it, and all of them have trade-offs. So there's not a right way. There's just the way that works for your team and your projects, and you need to know what those trade-offs are. We try to stay abstract, so our toolkits don't have opinions about the final styles that are output. Our toolkits only help us get there. Tools should fit you. I think this is obvious. A hammer doesn't just build patio chairs. You use it to hit things. You can hit anything you want. So build hammers. If you're building toolkits, it's important to test your logic. I've built a testing system for Sass. If you want to use it, it's just based on other testing systems and gives you some results from your Sass. I don't think it's important to test all of your CSS. This is not something that's useful to teams on a day-to-day basis building a website. This is useful if you're building toolkits, if you're doing something that has logic and output. Anytime there's logic, it's worth testing. It's also worth linting. This is pretty simple, and I think a lot of people are doing it already. Just letting the computer tell you when you're making little stylistic mistakes, keeping your code consistent across the entire team, and letting the computer do the difficult work there, so you're not fighting each other about white space. The important thing is, if you don't document something, it doesn't exist. In the first release of Suzy, I didn't document the functions. And then I didn't understand why nobody was using the functions, because they're the best part of Suzy. And it's because they didn't exist. Nobody is going through and reading all of the code. They want to know what's there and how to use it. And if you don't document something, nobody's going to use it. So figure out what's important in your code, make sure it's documented, and make sure people know how to access it. Let's look at some concrete patterns. I don't actually know what time I have. This still says 25 minutes, so I'll keep going. So concrete patterns can be anywhere from like icons to buttons to very specific widgets, a calendar. Here's a notification with icons, so we'll sort of plow through that. We use HTML templates. We use Jinja and Nunjux. I think templates are amazing. Templating languages are amazing. I wish they got the attention that preprocessors get. I think there's a lot more we could be doing with them, and I think they're really important. Patterns with a templating language like Jinja or Nunjux, which Jinja and Nunjux are the same basic language, but one's in Python and one's in JavaScript, so we can take the same template and show it on the back end or the front end. So in Jinja or Nunjux, this is turning a pattern into a macro, very similar to in Sass turning a pattern into a mixin. This macro takes some arguments and gives some output. So we say we want icon wave, hello world, and that gives us the icon. I think template logic is great. I don't understand languages that are trying to get rid of it. I think that's the same mistake that we made with trying to make CSS logicless. It's useful to have logic. There is presentation logic. We need to make decisions in our templates, and so it's useful to have those logical structures. But there are some gotchas around that, and some of these I picked up by following how the Sass language design worked and some mistakes they made and fixed along the way. It's important that the language be a superset. Pure HTML should be valid in your templating language. Those should be able to cross over. And that was why Sass now has SCSS, because pure CSS should be valid Sass. It's also important to clearly distinguish the new syntax. Sass made some mistakes with that early on. Things that looked like CSS, but actually were calculated and processed. And so I think that's also important. So you can see here with 2 templating languages, the top one is Jinja or Nunchucks, and you can tell what is HTML, and you can tell what is not HTML. They're clearly differentiated. And the pure HTML is also valid. And compare that to, from React, something that gets both of those wrong. You can't use class name. You have to use class name instead of just class. So pure HTML is not valid. And then also you have something that looks like HTML here and isn't. And so I think this breaks all the rules, and we should do better. Also, that I can't read the structure of that. HTML is all about structure, and this is not all about structure. JavaScript is not a universal solution. I know a lot of people know JavaScript, and that makes it easy to go to. It's not a universal solution. There's a reason we have different languages. I have several slides about this, just in case you forget. JavaScript is not a universal solution. Don't try to use it for everything. So I'm going to look quickly at the Salesforce design system. Their icons. And this is a great system. I'm not trying to complain about what they've done. Like I said, they have different needs than I do. I'm just going to make some changes based on what I would need. So you can't see very well here. This is the code for a single icon, a span, an SVG, and a use, and another span. So there's a lot going on there just to show one icon, which is great. That's fine. But you have to, in order to use this pattern in their system, you have to copy and paste that code. So there's a few things I would change. When I have several classes that are in the same system, so they had a small class, a medium class, and a large class, something like that, I would put those into a data attribute. And that, again, makes it clear, both in a computer-readable way and a human-readable way, that these things are part of one system. They're grouped. So instead of data SLDS icon color as a base part of a class name, I would get rid of the classes, all the separate classes, and I would make one data attribute. And then it's clear that text default, text warning, and text error are all part of the same pattern without adding that to every class name. I would do the same thing for the sizes. So again, move those into a data attribute. And then I would build a macro. So here's a macro. Define it. Give it some attributes, arguments. It takes a name and then possibly an alt and a color and a size. And then the template knows how to generate that. And we get, instead of the pattern being all of that code copied and pasted, the pattern is one macro that you call with a few arguments. And that's useful for handing that off to other developers. Much simpler and clearer. And you can document it. Here's turning that into using that with our colors and with our sizes that we generated earlier. We can just loop through them because we've got them all on a map and output exactly what we need there. So Herman also knows how to deal with icons. We point it to a folder with all of our icons, and it generates that because it has access to the macro and it has access to the icons. So that's, again, one of the things we're trying to do with Herman. Herman is still in early alpha. This is not a product I'm trying to sell at you. And it's going to be open source. But it's important to me that our style guides have access to real templates and real CSS so that all of that is generated. Anything we can generate automatically, we want to generate automatically. Anything that we can do based on living code, we want to do based on living code. So we're getting close to this notification. We've got our icons, but we need a macro also for the larger pattern. And within that, we can call the icon pattern. And you don't care about the rest of this, but here's a notification macro. And then we can document that. So we've been adding, our Herman now understands if we say that we've got a nunchucks example, it can access the correct code. Like I said, access that macro directly and display it somehow. We haven't finished this. We're still working on it. But poof, style guides. Great. So that's what we want. Style guides are about the output. But in order to get that output, we need consistent input, and that's code patterns. And that happens across languages, but in the code. They make the code readable, they make the code meaningful, and they live inside of the code so that when you are writing the code, you are using the patterns. Thank you.
Thank you very much, Miriam.